started volunteering at a school for kids with neurological diseases. Most of the kids at the school had a disease called cerebral palsy. This means that they have limited motor control over their muscles, and some of them can't even talk. One of the current solutions to help these kids communicate is speech therapy. But the problem with this is that it doesn't usually work. Another option is sign language. But the problem with this is since they have limited motor control over their muscles, it's really hard for them to actually make the signs to communicate. And the last option is doing text-to-speech. But then the issue with this is the same one that came up with sign language, where because they can barely control their muscles, it's hard for them to type anything on the keyboard to say out loud. So this is a really big issue. Over 500,000 people in just the US are diagnosed with cerebral palsy. My solution for this was to use EEG technology to make a brain-to-speech interface. Anytime you think of doing something or do anything, neurons in your head fire. When a single neuron fires, it's hard to measure, so we can't really access that information. But when groups of neurons fire at the same time, they produce large electric impulses that go through your skull and through your skin, and that we can now measure on the surface of on your scalp using electrodes. For my project, I used the Muse headband. The Muse headband is a 4-channel EEG. This means that it can measure electrical activity from 4 different parts of your brain. There are 2 main parts to the application. There's brain to text and then text to speech. For the brain to text part, the user uses the cursor to type on a keyboard using blinks and jaw clenches. And then the second part is text to speech. So the computer uses a speech synthesizer to convert whatever they typed out and say it out loud. So to detect whether or not the user blinked or clenched their jaw, we use something called artifact detection. So usually when you blink or clench your jaw, this is a really bad thing for EEGs because your muscles produce electrical signals that interfere with the measurements reported by the headband. But in this case, it's actually a really good thing because these interferences, which are called artifacts, actually tell us whether or not they blinked or clenched their jaw so we can look out for them. So this is what EEG data looks like. So you can see whenever someone closes their eyes or opens them, it produces spikes in the data that we can detect. And when they clench their jaw, it produces a large amount of interference because of the electrical signals from your jaw, and that's also really easy to detect. So this is what the app looks like. So every second, the cursor keeps going down through each row. And when the user sees the row that their letter's in, they clench their jaw. And then it selects that row. And then it keeps iterating through that row. And when it gets to the letter that they want, they clench their jaw again, and then that letter is taken, added to their phrase, and the cursor goes back to the beginning. In case they select the wrong row, they can just double blink and the cursor goes back to the beginning. Or if they select the wrong letter, they can take the cursor to the backspace key, which is this angle bracket, and then they can just delete a character. And once they're done, they just bring the cursor to the done button and select that. And now, every time they clench their jaw, the phrase will be said out loud using the speech synthesizer. Humans are social creatures, and talking is the main way that we interact with the people around us. So when you're a little kid and you can't talk, the world can be really lonely and it can be a little bit depressing. So brain-to-speech interfaces make it so that they can finally communicate with people around them and interact technology where they couldn't before. And we can take this a step further by using artificial intelligence. If we implement artificial intelligence into a program like this, we can make it so that it gives custom auto-completion. So as the person keeps using this program over a period of time, it'll recognize what words they use most often and in what pattern. So if I just type in H and the word I say most often is hello to people, it'll automatically give me a recommendation at the bottom to just autocomplete to hello. And with this implementation, we'll make it so that their words per minute will be so much faster and communication will be much easier. Maybe in the future, we won't even need brain-to-speech interfaces because maybe we'll just have brain-to-brain interfaces. And then we could just communicate using telepathy. And I look forward to seeing a future where this is possible. Thank you.
Cool.